Okay, now it's clear. See, that's why I stopped this video. See, so many parts I had a mistake. See, this is equation number 7 becomes like this. 4 and 5, connect the 4 and 5, it become like that. I made a k square also, 5 over 18, again 5 over 18 on this part, okay, that case. Now, 6 divided by 7, see, as I mentioned earlier, 6 divided by 7, here I shown this symbol, therefore 18, 5, everything cancel, this comes. Now I apply for the capital H value, or otherwise 3600 H over V. You know the power already. So what is 3600 H over V? This part, U mg sin alpha over V minus U. The same here, I apply the capital H value here. Then see mg sin alpha cancel, okay. Go through and check mg sin alpha cancel. So remaining U, I use the LCM V minus U, and here multiple, here 1, so V minus U. Here remaining part, check, we'll do that. So I can cut this 5 over 30, 10 over 36 means 5 over 18, right? And see this simplifying form. And finally, W square equal VU into 5 over 18. So what is 5 over 18? We used what? Kilometers per hour changed to meters per second. Kilometers per hour changed to meters per second. We use 5 over 18 multiplication. Then if you divide by 5 over 18, it becomes kilometers per hour. kmh minus 1. That's why here see there's additional 5 over 18. So W square is UV. So W equals square root UV. So 5 over 18 means that you have changed for kilometers per hour. So kilometers per hour to changing meters per second, we multiply by 5 over 18. And if you remove the 5 over 18, that becomes kmh minus 1, right? So very important. So many mistakes come. I also made a mistake due to this YouTube platform. I can't correct it. That's why I stopped the video and show properly shown and now described clearly. So practice more. It was like essay type question of like the structure maybe. Up to 3 capital H answer is okay. Hereafter some more simplification. Okay, we'll see next problem. See question number 4, the vector question. We complete many vector problems. See question. Draw the diagram, mark the details. So here I have shown so long videos because of the big questions, big explanation needed, some misuse, some mistake happens. In a parallelogram, right? See that parallelogram. Opposite sides are parallel. I mark O, A, where is here B, C like that. No matter whatever you mark, no matter. So the diagonal, 2 diagonal vectors are given. 2 diagonal vectors are given, A and B. Vector A and vector B are 2 diagonal vectors of a given parallelogram, right? If I say this is one mark there, so A is, no matter, this is okay. So can I say the AC vector is A, okay, and OB vector is B. 2 diagonal forms given vectors are A and B, right? Then they asked one of the angle of this parallelogram show cos inverse that solution, right? So can I take this angle? So they asked that also using the using the scalar product. You know, scalar product only we have the angle A dot B equal to what? Mod A mod B cos theta. Therefore, if you can find this OA vector and the OC vector, then you can product the both vectors OA dot OC, then you have a chance for answer. Therefore, try to find those vectors. You know, diagonals are bisects in each other for a parallelogram. If I mark this M, point is M midpoint, So if I take this AC is vector A, AM is half of the vector A, right? Therefore, AM vector is half of the vector A. Same as if I take OB is vector B, then what is OM? OM vector is half times vector B. Okay, so you know the AM vector, you know the OM vector, you can find the OA vector. Use the vector addition for triangle OAM. So in triangle OAM, use the triangle vector addition. Vector OA equal OM vector plus MA vector, is it? Is it okay? OA vector equal to what? OM plus MA vector. So OA vector, what is OM? Half vector B. MA is AM is half A. So MA is minus half A, right? Minus half vector A. Therefore, OA vector is, take the half out, B minus vector A, right? You need this part of the answer. Next we see the other, which one? OC. How to find the OC vector? You know the OM vector. You know the MC vector. What is MC? AM equal to MC. AM equal to MC. Therefore, MC also half A. Now come back. In triangle OMC. In triangle OMC, OC vector equal to what? OM vector plus MC vector. OM plus MC vector. So what is OM? Half B, half, and take the half out. What is MC vector? AM equal to MC. Therefore, that also half vector A, right? So can take the half out, therefore A. Okay. So you know the OA vector, you know the OC vector. Therefore, you use the vector product. Now we tell about that angle. Let AOC angle is theta. AOC angle we say theta. Therefore, by using the scalar product, OA dot OC equal to what? Mod of vector OA mod of vector OC cos theta. Okay, then write what is OA? Half B minus A. What is OC? Half dot half B plus A. And what is OA? Modulus, right? The mod symbol and write it half. So for a number, no matter the modulus, I take the half out. Okay, and the other one is half B plus A modulus into cos theta. See the both sides at half, quarter, 1/4 cancel. You know what is, now you multiple B dot A, you know B dot A mod B into mod B cos, no, therefore mod B square. A dot A also mod A, therefore mod A square. So in that case you cancel these things. Therefore here mod B square minus mod A square equal to, what is B minus A modulus, and can I say B plus or A plus B, no matter, into cos theta, Therefore, subject the cos theta divide by those b minus a. Inside the mod, no problem, a plus b, a minus b, no matter inside the modulus. Therefore, theta equal cos inverse. Cos inverse, okay, that answer, right? Everything is okay. OA equal OM plus MA. OM is half B. MA, I said AC is the vector A. MA minus vector half A. Therefore, I took this A out and simplify. Subject the theta. You have the answer cos inverse, right? See question number 5. So it is using the scalar product, one of the structure type problem in vectors. Okay, that question number 5. A solid uniform sphere of W is placed on an inclined plane. Go through and read that. Friction problem. Friction. The angle is alpha. A sphere is kept like this. It will roll down to avoid the slip. They tie the string mark horizontally to the plane, right? At the top of the sphere, they tied a string, attach a string, and the other extreme at the inclined plane, right? So now show the forces. You know the weight is always at W. It will roll down. Therefore, friction act opposite that. And here a tension force. I am showing the equilibrium of the sphere, right? And the reaction force are, okay, these are the forces act on this sphere, equilibrium of the sphere, its weight W, reaction used by the plane to the sphere R, tension in the string T, friction force F. They say mu is the coefficient of the restitution. So this is in equilibrium. Therefore, show that alpha less than or equal to tan inverse mu. Alpha less than or equal to tan inverse mu. So what do you mean that when the inequality form in the friction problem for equilibrium, what that F over R less than or equal to mu. F over R less than or equal to mu. So if you find the F value and the R value, go to the answer. Simple question, well balanced for the structure type. I hope you complete this, therefore check with me. So the alpha therefore is also alpha, alternate angle. I say radius of the sphere is O, we take O, everything cancel later. Okay, now you know the static problem solving, resolve the forces or take the moments or Lami's theorem like that. Okay. So first I will find this Ft. So write this sentence. For equilibrium of the sphere, take moments about O, take moments about O, take moments about O, and write the O. Can I take the F direction? Take moments about O. What is moment? Force into distance. So F into A. Okay, distance radius A. And T come other side, minus T into A equal to 0. Okay, so no A cancel, therefore F equal to T. If you know friction force, that is the tension. If you know tension, that's the friction, right? So you can't take the R because R passes through the O, W also through the O, right? Okay, next right. Resolve the force along the slope. Resolve the force along the slope. What happened? Resolve the force along the slope. Capital F plus T cos alpha. Okay, check will you. Plus T cos alpha. Plus T cos alpha. And you can't take the R because R is perpendicular. R cos 90 is 0, you can't take the R, but the W component is solve here alpha, check here alpha, 90 minus alpha, here alpha, check value, okay. So W cos alpha, then W sin alpha downwards, minus W sin alpha equal to 0, okay. Check the second equation. Now connect the both and try to find the T answer or the F answer. So 1, 2. So 1, 2 gives you F4T here, T plus T cos alpha equal W sin alpha. So take the cos and cut it, take the T and divide by that. W sin alpha over 1 plus cos alpha. This is F now. That also F and T are both equal, right? Okay. Now the idea in the friction problem, find the F, find the R, F divide by R less than or equal mu. Okay, now we come to, now write, resolve perpendicular for equilibrium of the sphere, resolve perpendicular to the slope. So resolve upward, what happened? R up, R is up, W cos alpha minus the, okay, minus W cos alpha. Now the T component, we say T cos alpha here and T sin alpha down, right? Minus T sin alpha, okay, equal to 0. Therefore find the R answer. What is our answer? W cos alpha plus T sin alpha. What is your T? W sin alpha over 1 plus cos alpha into sin alpha. Can I say sin square alpha? Therefore R equal to, take the W out, and simplify this. If I multiply here, cos alpha, cos into cos square alpha plus sin square alpha. Okay, so what happened? R equal cos square plus sin square is 1. So 1 plus cos alpha cancel. R equal to W. Check your answer. I hope you work this question. Simple. R equal to W. So write next sentence. For equilibrium, F4R, or for limiting equilibrium, F4R less than or equal mu. F4R less than or equal mu, right? So go to the answer. What is your F? Write your F. Here you have F. W sin alpha over 1 plus cos alpha into R. R is W. Check W less than or equal mu. So what happened is that answer. W cancel, check value, W cancel, sin alpha over 1 plus cos alpha less than or equal mu. This is also one of the answer, but they ask tan theta, tan inverse mu, right? Therefore no sin, no cos. So use your trigonometric issues, use your double angle formula. What is sin 2 theta? 2 sin theta cos theta. Therefore write that. 2 sin alpha by 2 into cos alpha by 2 over what is cos 2 theta? 2 cos square theta minus 1. So what is cos 1 alpha? 2 cos square alpha by 2 minus 1. So 1 cancel. 2 cos square alpha by 2 less than or equal mu, right? Therefore find the answer. 2 cancel, 1 cos cancel, sin alpha by 2 over cos alpha by 2, that is tan alpha by 2 less than or equal mu. Therefore alpha by 2 is the answer is provided. Tan inverse mu, otherwise cos multiple alpha 2 tan inverse mu, right? This is the answer here. So alpha less than or equal, therefore the biggest value, maximum value of the alpha is this, okay? The last part, find the maximum tension in the string in terms of mu. So you have the tension, you have the tension, that answer. So your sine, cos. So using this you can't find the maximum, minimum, because when sine increasing, cos is decreasing. Anyhow, they ask in terms of mu. What is in terms of mu means tan alpha. You have to change the question in terms of tan alpha. Therefore, write once again t equal that and go to the t in terms of tan alpha pattern. Change the t into tan part, right? So what is that? W, as we worked earlier, same idea, sin alpha is 2 sin alpha by 2 cos alpha by 2 over is what? 2 cos square alpha by 2, okay? So what happened now? To cancel W tan alpha by 2. W tan alpha by 2. Then tell the maximum value of the t. When t becomes max, tan alpha becomes max. Tan alpha maximum infinity, tan 90. Don't say that value in this question they ask. In terms of mu, here we have the answer. Tan alpha by 2 maximum is what? Mu. It was mu tan alpha by 2 less than or equal to mu. Therefore maximum answer mu, other smaller than that. Therefore write a sentence. For t maximum, tan alpha by 2 should be maximum. For t maximum, tan alpha by 2 should be maximum. But the maximum value of the tan alpha by 2, write this, but the maximum value of the tan alpha by 2 is mu. So write the answer. Therefore, T maximum answer mu W or W mu, right? That's the question. I hope before me you completed successfully simple well balanced question. Friction involving that some trigonometric part. Okay, see next question, the circular motion. What is the circular motion? A particle of mass m is attached from a light inextensible string of length a attached to a fixed point O. The particle is horizontal, project the velocity is usual in the vertical circular motion. When the particle equilibrium, show that the particle moves out of the circular motion when it is at a vertical height 2a by 3 from O. Just to complete that part. So if I show by diagram initially, it's the initial story like this. Then they give a velocity u. If I say u is what? 2 times square root ag. U equal 2 times square root ag. If I say time is 0, the late age moves somewhere here. I show separate diagram. Somewhere here. Okay, this is the line of the lowest point of the equilibrium position initially. usually take the theta, the angle theta or alpha. You can mark those part. And this point O, here the point is O. The length of the string is A, that is A. I show the force mg and tension T, velocity V, and if I take this the height, because the question is about the height first occasion, they ask this about the height when circular motion out of. What do you mean out of the circular motion? Maybe no tension, string is break or string is slack. It will move different if you learn in the theory classes, move by projectile motion or some different oscillation like that. Okay, now what we use in this kind of circular motion problem, principle of energy, conservation of energy, and the F equal ma formula. So can I use that one? So write this below. By taking the horizontal line through the initial point as zero energy level, apply the conservation of energy. Apply the conservation of energy, half mu square, initial kinetic energy, potential zero, because I take this is the line of E0 line, right? This is the E0 line, energy zero line, right? And come here, kinetic energy half mv square plus what? mg. Can I use this 8? Or you know this a minus a cos theta. I take this height, mgh, height, mgh. From that above the ground, I take the mgh. Now I can cut by m, and multiply 2 and solve it. You can write the u square answer also. What is u square? 4ag multiply 2v square equal what here? Multiply 2, say value 2gh plus 2gh. Therefore v square equal 4ag minus 2gh, right? Is the velocity of this particle after moving this angle theta or above the ground level, height is h. Next apply F equal ma at this time is t, right? Time is 0 there. Apply F equal ma along the center, towards the center. Apply F equal ma. So what is that? T minus, you know, here theta, mg cos theta, okay? T minus mg cos theta equal mass is m, but the acceleration, like this vertical circular motion, the v is tangent velocity is v square over radius. So v square over a. This length is a, right? So I say this is first equation, here second. So the problem is find the t value first, connect the both. So 1, 2 gives you t equal mg cos theta plus m over a, what is v square 4ag minus 2gh, okay, is the t answer in terms of that height. Okay, now they ask when t is 0, particle out of the circular motion, the height is that. So I want to find the small h answer when t becomes 0. So write below, when t is 0, when t equal to 0, so 0 equal mg, you can find the, what is cos theta here? What is cos theta, this one? What is this part? Completely A, this is h, so a minus h. A minus H over hypotenuse A, right? Plus M over A 4AG minus 2GH. By solve, find the H value, M cancel, find the H value. So divide by A, okay, take the 1 over out, see 1 over out, or divide by, do the rest. Take that, you can cut the G also, MG cancel, right? G cancel. So 1 minus H over A plus multiply by A 4 and minus 2H over A. Therefore 5 equal 3H over A. So the height above the ground is located, will you, 5 over 3A. Check will you, 5 over 3A. H equal 5 over 3A. So what do you mean 5 over 3A? This is radius A. This is more than A. This is maybe 1 point something more than A. Therefore, from here, this is A. Therefore, actually particle leave second quadrant. So those well learned this circular motion. The theory class we teach that method. So many condition of circular initial speed, it oscillates below the lower quadrant. Second quadrant go to the move by the projectile motion. And the higher speed is a just circular motion. So many conditions depending on the initial speed, right? So I hope you learn successfully those things. So here what, from here 5 over 3A. So what the question, when it is a vertical height of 2A 3 from O, vertical height 2A over 3. 2A, so from O, so find the, this from here, so from O they ask, from up they ask, what the answer they are for? Subtract A, subtract the radius, the total height is this, so from O you subtract the A, you have right answer, therefore height from O, so we measure from the ground level, so from O means up this one. To find from, subtract the radius, right? Therefore, the height from O equal 5A over 3 minus A, but that 2/3 A, okay? 2/3 A from the vertical upper point, right? Above point, A by 3, 2A by 3, that's the answer, okay? Another part, go through and see what that. Find the tension in the string when the particle vertical height A by 3 from A, from O, A by 3 from O. Okay, then come to the answer. You have T. You have the T answer. So put that H4. H4, that expression apply and find the answer. Tension, what is the tension when the height is that? So after completing, you have the answer is 30, put that cos theta for A minus H over A, cos theta for A minus H over A, apply a cos theta for A minus H over A, and rearrange the expression for in terms of H. So you can complete that. Try this answer. T equal M over A 5GA minus that 3GH to simplify. This is the tension force generally in terms of H. We can work this for cos theta. Is here is T. T, and if you simplify, get this answer, right? Now that's easy now. If H equal height is A by 3 from the vertical from O, therefore when H equal A by 3, put H for A by 3, find the T. if H equal A by 3, what is the equal M over A 5GA, what is 3H? 3H is A, right? 3H for AG, 5AG, 4AG, so A cancel. Is it 4mg? I hope you complete this, not a difficult problem. Simple, well balanced for the structure type question. A vertical circular motion, right?